Alright, so I'm recording this video basically for those who are absent or just didn't quite get to you. But basically, I'm going to try to split this video up into two parts. Okay, so this is section 2.1, graphing absolute value equations. Okay, so let's start with the definition of an absolute value. So an absolute value is basically a distance measured between a certain number and 0. So for example, if x equals 5, we know that if we consider these 2 points here, -5 is 5 units away from 0, and we also know that 5 is 5 units away from 0. Now, if we're using an absolute value, we want to consider the positive distance between those points. So that's why when evaluated, an absolute value is always positive. So basically, this here is a short way of saying the absolute value of a certain number. So for example, what I did here is that this says the absolute value of -5, so all the negatives in here will become positive. So the absolute value of -5 becomes a 5. Now if you take an absolute value of a positive number, it'll always spit out a positive number. Okay. Next part. An absolute value can also be written as a piecewise function. Okay. The reason why I want to present this before presenting this is just so you see a different example of how to represent piecewise functions. Okay. So, for example, we have something like this. So, so you can kind of interpret what's happening here. So, this is, if I were to extend this line all the way through, this is basically a line, just the y equals x line, only from 0 to 2, because it's stopping right here, and it changes to a different line. Okay, a different line segment actually. Okay. Next, so now I want to consider the line y equals 2. So if I were to close this, off, and if I create a line going across like this, so basically I'm considering a line with a slope of 0 and a y-intercept of 2. Okay, so that basically this here is going to be from 2 to 4, and it has a y-intercept of 2, slope of 0. This part here, if I were to close this off, we're considering the interval from 4 to 6. Now the equation for this line, if I extend this all the way down like this, basically the y-intercept is going to be 6, and then the slope is going to be -1. The slope is going to be -1, so that represents, this is going to be the function x plus -x plus 6 from the x interval from 4 to 6. Okay, the absolute value function. Okay, so this is basically the notation for the absolute value function. So it can be defined piecewise by the following. So basically, what this means is that if you put like a -1 here, it's going to spit out a +1. If you put in like a -5, it's going to spit out a +5. Here, if you put in a 8, it's going to spit out a +8. And then if you put in if you put in like a +15, it's going to spit out a +15. So all negative numbers will become positive, and then all positive numbers will still become positive. So let's try to fill in this table here on the side. Okay, that's why I put this table here on the side for you to look at. So basically, if your input here is -2, basically this here will make it positive, because all negatives in the absolute value will become positive. So -2, absolute value of -2 becomes a +2. Absolute value of -1 becomes a +1. If you take the absolute value of 0, that's going to be 0. Absolute value of +1 is 1. Absolute value of 2 is going to be 2. So just remember, if you have a negative number, it's going to become positive if you have this thing called an absolute value. So let's put these numbers here, 2, 1, 0, 1, 2. Now if I plot this, So this is negative 2, comma 2. This is negative 1, comma 1, 0, 0, 1, 1, and 2, 2. Just like that. So if I were to graph that, that would be my absolute value function. So the absolute value, the graph of an absolute value follows the shape of a V. It always follows the shape of a V. So just try to remember that. Okay. An absolute value equation has the form f of x equals a. So a, this is my vertical shift. And then you have the absolute values here. This is x minus h plus k. So h and k will represent your vertex. So vertex, if you don't remember from like, I don't know, geometry, like if you have an angle where the lines meet, that's called the vertex. So basically an absolute value, if you have absolute value like this, the point where it changes, that's considered the vertex. Okay? Alright, so we'll see these later, and I'll explain how to do these types of problems later. Now, if you see in your book might have a different equation from this. I'm going to show you how to deal with it with the problems later, because basically what's going to happen is it's like a 1 over b here, and basically you could pull that out because if it's negative or positive, it'll just come out anyway, and all you have to worry about is if it's a vertical, oh, you know, shoot, this is a vertical stretch or compression, my bad. This is a vertical stretch or compression. Yeah, I think had an idea what I meant by that. Sorry about that. Okay, we'll refer to these steps later, how to graph an absolute value equation. I'll refer to that when we actually I'm going over the examples now, so I am going to refer to this. Okay, so you want to identify the vertex and then look at this here to see how it vertically stretches or compresses. Then since you want to create this V, once you know where the vertex is, just plot a point to the left, plot a point to the right, and then create your V. Okay, so enough of me talking. Let's try to go to an example. Okay, graph the absolute value equations. Okay, so if you want to graph the absolute value equations, okay, so basically what we're going to do is, I'm just going to do this by steps. So step 1, so identify the vertex. So what we know is that our equation for absolute value is f of x equals a, and then you want to consider the absolute value of x minus h plus k, just like that. Okay, so what I see here is that my vertex is going to be hk. So if we look at what h and k is, h is 5. My k, look at this here. So because this is not, if it was a plus 2, then it would look like this. Do you see that? If it was a plus here, it would be a plus 2. We have a negative here, so that means our vertex is going to be 5 comma negative 2. Okay, so I'm going to plot that there. So it's going to be, this is 5, negative 2 is about there. Okay, step 2. Plot a point to the left of the vertex. So let's choose an arbitrary point. Let's say we use x equals 4. Left of the vertex. So if we go left of the vertex, let's say we use x equals 4. Okay, so what we want to do is we want to try plug this into here. Okay, so this might require a little bit of algebra, but basically if I find the g of 4, so it's going to be 4, and the absolute value of 4 minus 5 minus 2. So if I were to simplify this, This is 4, and then 4 minus 5 is going to be a negative 1. It's going to look like this. Now, this here, this is going to become a positive number, right? Because the negatives inside the absolute value become positive. So this is 4 times 1 minus 2. Okay, so 4 times 1 is a positive 4, minus 2 is 2. So if I were to create a tiny XY chart here, one of our points, we know x is 4. When x is 4, y is going to be 2. Okay, so that's going to be 4, comma 2. So from here, let's think about it. So we look back at our vertical stretch or compression. We know that this is greater than 1. Because it's greater than 1, we know it's going to stretch up. And so we know that we're doing our calculation correct. Okay, so the next part. Let's say we want to plot a point to the right of the vertex. And let's say we use x equals 6. Okay, so when you're plotting the values for an absolute value, the slope on the left hand side is just the negative of the right hand side, or if it's flipped across the x-axis, it will be the opposite way. But basically, we want to try see if we plug this in, if it's going to be different than 2. But assuming that we do the calculations correctly, it should be okay. So g of 6 equals 4, and then you have the absolute value of 6 minus 5 minus 2. So what we see here is that 6 minus 5 is going to give me 4 times the absolute value of 1 minus 2. Okay, the absolute value of 1 is just going to be a positive number. So this is just 4 minus 2, which gives me 2. Right? So we know that from to the right of the vertex, we know that for an x value of 6, y is going to be 2. An x value of 6, y is going to be 2. So if you want to graph this absolute value equation, it just goes up like this, and this just goes up like that. Okay, next one. Okay, actually, let's see. I'll cut this video off. I think I'll cut this video off, and I'll start part 2. So part 2 of this video, hopefully that will be the last of it. Yeah, so on to part 2. Bye.